All right, so when we are given a word problem where we have to find the formula and find the equation from words, we can follow these 5 steps up at the top. This is also in your OneNote for you to reference. So I have, write the balanced formula for the following. When heated, solid tungsten metal reacts with oxygen gas to produce solid tungsten, and that is 6 oxide. So the first thing I have to do is identify my reactants and my product. So I'm going to highlight my reactants in yellow. So I know that when it says solid tungsten reacts with oxygen gas, those are going to be my reactants. I start off with tungsten and I start off with oxygen gas. I can clearly see also that it says to produce, and that means products, solid tungsten 6 oxide. So this is going to be my product. So words that say react with, like this is always going to be a hint that whatever is next to these, like before and after, are your reactants. And then produces is whatever comes after that is usually your product. So I did number 1. My reactants are yellow, my product is green. Identify the element symbols and compound formulas for each. All right, so I have solid tungsten. So tungsten, if I go look at a periodic table, tungsten is right here. Tungsten is W. So I'm going to go back. Boom, nope, not that one, this one. And I'm going to be like, oh, I know what this is. This is a W. Boom. Oxygen gas. I know that oxygen, by now we've seen oxygen a whole bunch of times. Oxygen is just a capital O. However, oxygen is one of my atoms that loves to have a buddy. It loves to be a diatomic molecule. So it says oxygen gas. That means that it has to be O2. You have to remember that oxygen, nitrogen, chlorine, fluorine, hydrogen, all of those, if they are in the gas form, they are going to have a buddy. They're always going to be diatomic molecules. All right, and last one, I have to figure out what this compound formula looks like. So I know that tungsten is W. I know when transition metals have this little Roman numeral next to them, it is talking about the charge of my metal. So this tungsten has a charge of +6, and oxide is referring to oxygen. So if I have +6 here, I know that the charge of oxygen is always going to be -2 because oxygen is in this row right here, and this row is always going to be a -2. It is 1, 2 away from a noble gas, so it is a -2 charge. Let me go back. There it goes. Okay, so I know that my oxygen is always going to be a -2. Now remember, to figure out compound formulas, I have to have my charges balanced. So I have a +6 here and then a -2. I'm going to add another -2. Now I have a +6 and -4 total here. So I'm going to add another -2. And now I have, let me draw a little line right there. I have a +6 charge, and I have a -2, -4, -6. A -6 charge. So now my charges are balanced. That means that I am done writing the compound formula. So I have 1 atom of tungsten, and I have 3 atoms of oxygen. 1, 2, 3. All right. So now I have all of my element symbols and compounds ready. I watched out for diatomic elements. I had one. It was oxygen. So I'm done with step 2. Number 3. Write the skeleton of the chemical formula. So my chemical formulas are always going to have like something reacting with something, and it's going to produce something. That's my skeleton. So I already said that my reactants were the ones in yellow. So I said that tungsten reacts with oxygen gas, which is O2 here, to form this one, WO3. Boom. That's my skeleton. I put the reactants on the reactant side. I put my products on the product side. I have my plus sign and my arrow. All right, I check mark that. Now I have to include the physical states, meaning solid, liquid, gas, aqueous. Usually, if this is a requirement, the problem will tell you. So it does tell me I have solid tungsten. So this one is actually a parentheses S for solid. Oxygen gas, so this one is actually parentheses G. And I have solid tungsten oxide, so this one is going to be parentheses S. All right, so I did my phases. Balance your equation, and this is the easy part. We've been doing this for a while now. So I have one W, I'm going to write it right here. I have W and I have O, tungsten and oxygen on the reactants and the product side. So right now I have one tungsten on this side and I have two oxygens on this side. So I have one tungsten, two oxygen atoms on my reactants. I have one tungsten and three oxygens on my product side. So what happens, let me write a different color here, let me do blue. What happens if I multiply this side by 3, and I'm going to multiply this by 2. And what that translates to is on the reactant side, I'm going to multiply my oxygen atoms by 3, so I'm going to put a coefficient of 3 here. And then on my product side, I'm going to multiply my oxygens by 2. So I have to put a 2 coefficient here. So now I have 6 oxygen atoms on the reactant side, and I have 6 oxygen atoms on the product side. But because I have this coefficient here, now on my product side, I have 2 tungsten atoms, and I still have only 1 tungsten atom here. I can easily solve that and put a 2 in the front here. So I'll have a 2 in the reactant side. And now I just check. I have 2 tungsten atoms here on my reactant side. I have 2 tungsten atoms on my product side. I have 6 oxygen atoms on my reactant side. 3 times 2 is 6. And I have 6 oxygen atoms on my product side. 2 times 3 is also 6. So now this is my formula. I have balanced it and I am done.